Welcome to this section about firewalls and honeypots. Let's start about asking a question: why using a firewall? What is the firewall? The firewall is one of the most effective and most common security tools. It protects the internal network from users inside the external network. The internal network could be the network of your enterprise, the network of your company, the network of your bank, and the external network is the internet, the vector of all the wicked people on the world. So you must protect your internal network from the external threats, from the attacks that might arrive to your network from all over the world, from people that may be intentionally or accidentally wanting to hack or attack or break the confidentiality or integrity or availability of your data. The firewall resides between these two networks, between the internal and the external. The firewall placement is between two or more networks to offer protection for one of them against the other. It offers the protection for your internal network from the external by residing between both, by acting as a gateway that inspects all the traffic arriving to your internal network from the external network. It controls the traffic between these networks, controls by inspection, controls by allowing and negating such traffic, controls by saying that this traffic is good, it can arrive to my network, and saying this traffic is not good, so it is forbidden to enter my network. This type of control is an art because it needs the firewall to be placed in a place that is a bottleneck, that is a gate for your network to be able to inspect and control all the traffic, not just some of it, all the traffic arriving to your internal network from the external network. The firewall is a very effective tool to prevent unauthorized access, to prevent breaking confidentiality, integrity, or availability, to prevent any unauthenticated reading, writing, modification, deletion for your important data inside the network. Once again, why do we use firewalls? Let's have a look at this diagram. The firewall is at the center, and we have so many P letters inside this diagram. Every P is a probability. You can see that there is a probability of indications and warning at the right side. That is probability of indication and warning of attack before it arrives to the firewall. And so let's this indication and warning be through the border router that has, for example, an access control list and residing between the firewall and the internet. It can indicate, it can send warning, it can even detect the attack and negate it and act as a wall and act as a something that makes the arrival of this traffic forbidden inside the network. So you have a probability of early detection, you have another probability of early negation, for example by the border router residing between the firewall and the internet that can detect and negate any malicious traffic from arriving to your network. When this malicious traffic bypasses this border router, arrives at the firewall, you have another probability of detection and negation. This time it is not an early detection or negation, this time it's common detection and negation by the firewall itself. If this traffic for a reason or another bypasses the firewall, enters your network, so you have another layer of defense inside your network that resides behind the firewall. Maybe this is the personal firewall on each device. Maybe this is the antivirus residing on each device or on each machine inside your network. So you have another probability of late detection and late negation. Why do we call this late? Because the traffic has already bypassed the firewall, has entered your network, maybe has caused some damage to your machines. So this detection and this negation is late. Of course, a good security officer, a good security specialist act as an engineer to maximize the probability of early detection. early negation of detection and negation, and minimizes the probability of late detection and late negation as much as possible. It is not a very big problem that you detect or negate late. Of course, the big problem is that you do not detect at all, or you do not negate at all. But try to work on the side of early detection and early negation, of detection and negation in common, but try to let it minimized, that you detect and negate late, that you depend on the host defense machines, the host firewall, the host antivirus to detect and negate the attacks arriving to your network. The benefits of the firewall are so many, because the firewall protects internal and external systems from your attack. The internal systems is the internal servers you have. External systems is the servers also you have that need to be broadcasted over the internet. Remember, we have the web server, the mail server, the DNS server needs to be protected and needs also to be exposed to the internet at the same side to act its functionality, because it needs to be a DNS server to receive queries and send responses, so it should be exposed to the internet. The firewall filters the communication based on content. It says that this packet is okay, it can pass. This packet is not okay, so it cannot pass. This type of filtering is based on the content, and we here mean by the content the header and the body of the packet itself. Based on the header, you can filter some communications. Based on the body of the packets, you can filter some other communications. And in all, the firewall should be able to detect and read to the most level of the packet to be able to filter the communication based on the content residing on it, either the header or the body. The firewall can perform the NAT by itself, the network address translation. It can act as the device intermediate between the internal network and the external internet. The device intermediate between the private IP addresses starting by 10 dot, for example, inside your internal network, and the external internet, which you must be represented on it through one real IP address. Some firewalls can perform this network address translation. This network address translation by itself is a means of protection, is a means of security. It can prevent the direct communication between external machines on the internet and internal machines on your network. This is some form of protection that saves a lot of effort by itself from letting the attacker communicate directly to your machine. The firewall has a very good advantage and a very good feature. It has the advantage and the feature of logging. Logging means recording. Logging means writing every packet that it has denied in its log file, which aids in intrusion detection, which aids to know who is the attacker through the source IP address of this denied packet. Who is the attacker and how is he attacking my network through the port number, for example, on this denied packet. And it is very helpful, this logging, in forensics, in going to the court and saying that this man, this attacker or this network is trying to breach the confidentiality or the integrity or the availability of my network. So it's very helpful in finding evidence, in recording evidence, and in detecting the attackers and asking for some help in defending them from the authorities. There are some shortcomings of the firewalls, and we insist on mentioning them because some of the security specialists think that the firewall is everything. Once you have placed your firewall, you are protected. This is not true. Firewall is never an everything, and there is not a single technique in security that is everything. Everything means everything. Everything means that you use all the possible techniques: encryption, passwords, antiviruses, firewalls, IDSs, IPSs, every possible technique for protection to protect your network and to protect your machines. So there are some shortcomings of firewalls, that attacks at the application layer, at layer 7, layer 6, layer 5, or at layer 7 may sneak through because the firewall cannot detect the attacks inside the content body of the packet. If I will apply the rule on the firewall that it sneaks every bit and byte in the packet, it would lead to very slow performance of the network, because every packet will arrive needs to be inspected fully before passing inside the network. This would lead to a very slow network, and that's something that I do not need to do. So what's the alternative is to let the firewall only expect the header. That would be fine and leads to fast network and at the same time protected network. Some connections may bypass the firewall, like the dial-up connection from the telephone line, the virtual private network connections, the VPN, or the connections from my extranet. These can be some connections that bypassing the firewall, and the firewall rules are not applied on them. Some organizations may let down their guard on other security areas, such as using passwords, patches, encryption. They let down their guards because they think firewall is enough. The firewall is there, it is expensive, it's working, it says that everything is good, so it is enough, so we can use weak passwords. We do not need to patch our systems, we do not need to apply encryption algorithms, and this is not true. If you apply such techniques like strong passwords, patching and updating the operating systems of the machines using encryption whenever possible, you will have better security and you will have much more better traffic inside your network than what would the firewall only lead to. Where to place the firewall? We have seen in previous lecture a placement of the firewall, single firewall between the internal network, the demilitarized zone, and the external network, which is the internet. Here we can see another example of the firewall placement. You can place two firewalls. One firewall between the internet and the demilitarized zone, where your web server resides. Another firewall between the demilitarized zone and your internal network, where your data and precious servers resides. So you can have two firewalls acting as two layers of protection, acting as two layers of filtering the communications between the internet, where all the evil lies, and between your internal network, where all the precious things and all the data and all your employees are working and all the things that you care for are residing. You now have two layers of protection, two layers of inspection for the traffic arriving from the internet to your internal network, and one of them is filtering the communications arriving to your demilitarized zone according to some rules. The other is filtering the communications arriving from the internet and from the demilitarized zone into your internal network according to other rules. This would lead to some form of security to your internal network from external attacks. Thank you.